All right, we are back and we're on page 169 and we're talking about conic sections. In the last video, we took a look at a GeoGebra thing where we were able to figure out like what are the conic sections. So you got a point, a line, a pair of intersecting lines. Those are degenerate cases. They can happen when you intersect a plane with a cone, but like it's not what anyone means when they say conic section. Then we get a circle, an ellipse, a parabola, a hyperbola. Those are the conic sections. So the first one we're going to talk about is the circle. Probably the easiest one to deal with, and you already probably know a lot about it. So the definition of a circle, it's the set of all points in a plane that are a fixed distance, which we call the radius, from a fixed point, which we call the center. So we probably already knew that. We can actually use that definition to find the equation. So that's what I'm going to do. So I'm going to say, let's let xy be on the circle. So this will be a point on the circle. And then, so the distance between xy and the center, hk, has to be a fixed number, the radius. So the distance is going to be x minus h squared plus y minus k squared. And that's that fixed number r. And then what you do is just square both sides. And there you have the equation of a circle. So like they're very straightforward. So this will be x minus h squared plus y minus k squared equals r squared. And that's all there is to it. So that's pretty good. Now let's see if we can use it for a couple of problems. So find the standard and the general form. So standard form is the nice one. It's the HK form. General form is the expanded one. It's terrible because there's just a lot of algebra. And it's like, I want to say that it's kind of like useless. It's not useless. It's just that like, oh, once you get it, if you're given general form, what you should pretty much do is put it in standard form. So like, why are we going the wrong direction? But we're doing it anyway. So this is done, right? That's our standard form. Now general form, x squared minus 24x plus 144 plus y squared plus 6y plus 9 equals 196. Okay, so x squared, okay, that's a squared. X, maybe bigger, x squared plus y squared minus 24. I always forget that like this isn't paper and I can like zoom in and zoom out and all those kinds of things. So what do we have here? We have 153 on the left, and I'm going to subtract 196. So I think that's negative 43 equals 0. I believe that to be the case. So this, I think, is going to be my standard form, my general form. Sorry. Woo! Confusing words. They're not confusing. I'm confusing them. All right, how about this? Identify the center and radius. Okay, so the center is definitely, so it's hk. It's x minus h, y minus k. So x minus negative 16. So negative 16 and y minus 0. And then my radius, don't forget that's the radius squared. So the radius is going to be the square root of 214. And then we're putting this in general form too. I don't know why we're doing that so much, but x squared plus 32x plus 256 plus y squared equals 214. So x squared plus y squared plus 32x. And then we subtract, so minus, what do we get? 42 equals 0. And we can check that on the calculator, which I will in a second. I like to save the calculator stuff till the end in case there's someone who's like such a pro at the calculator, they don't need to spend any time on that. Find the standard and general. Why do we keep finding general form? Find the standard and general form of a circle, the endpoints of whose diameters, no, of whose diameter, what are we reading? The endpoints of the diameter are these 2 points, negative 14.9 and 26.3. I don't know, reading's hard. So, all right, so we have the endpoints of the diameter. So it's like we have this and this. We need this, and then we'll have this perfect circle that I totally freehanded, like that. Okay, so that's what we have. So I'm going to find the midpoint of these points because that should be the center. So the center is going to be negative 14 plus 26. I guess I could write that. And then divide by 2, and then 9 plus 3 divided by 2. So this is 12, so 6, and then 6, 6. Look at that. All right. Now I need I can do 2 things. Well, 3 things really. I could find the whole diameter and divide by 2. That would give me the radius. I could find the distance from the center to this point, or the center to this point. I'm going to do, I think I'm going to do the center. I'm going to do the center to something. So I'm going to use, what am I going to use? I'm going to use this point and this point to find the radius. So the radius is going to be the square root of, because it's the distance between. So 26 minus 6 is 20 squared, plus 3 minus 6 is negative 3, but then squared is 9. So radical 409. Okay, so I'm ready to write the standard form, because standard form is the best. So equation, standard form, x minus 6 squared plus y minus 6 squared equals 409. Because don't forget, you got to whatchamacallit, square the radius. That's one of the biggest mistakes I see. Let's expand. That'll be fun. X squared minus 12x plus 36 plus y squared minus 12y plus 36 equals 409. So what am I doing? I got x squared plus y squared minus 12x minus 12y. 409 minus 72 is 337, but negative because we're bringing the 409 over. 0. Okay, so I think both of these are my equations. So let's highlight them. This is my standard form, which is the useful one. This is my general form, which is like, okay, like what would I do with that? I would try to put that into standard form. All right, let's use the calculator to help us out on these and just check. So if you're good, you're good. You can get out of here. Otherwise, hang around. So if I just have x minus 12 squared plus y plus 3 squared equals 14 squared, I'm gonna hit enter and see what happens. Okay, and then I want to subtract 196. You can just literally press minus, and I have to choose answer minus, because there's a minus and then there's a negative sign, and when I press it on the keyboard, it just like, I don't think it's set to either one, so I have to choose, which is like convenient, but also annoying. So minus 196, and we get that, which is what we got. So good job, us. Let's see, when we do x plus 16 squared plus y squared equals 214. And then again, I'm going to subtract 214, and I get this, which is not what we had, because why? Why are you not what we had? 256. It was just supposed to be plus. My bad, my bad. Oh yeah, because the bigger number is, oh God. Bigger number was on the other side. So I just fixed that in the notes. Hopefully you did too. All right, so let me show you a weird-ish thing that we can do here. So I'm going to store the points of the diameter, the endpoints of the diameter, as vectors. And then I'm going to treat this problem as kind of a vector problem, right? So I need to find the midpoint, but you can like add vectors, right? And you can scalar multiply. So I'm just going to do a plus b divided by 2. And that gives me the midpoint. That's the center. And then what I want to do, I'm going to do something really weird. Maybe, potentially. Like, what if I did the norm of xy minus the center, which is 6, 6. So that's x minus 6, comma, y minus 6. Then I'm going to find the norm of that. And it should, and I want to square that. This is getting complicated. Okay, so what, that gives me that. So what just happened? Well, let me complete square on the answer, comma x, comma y. Look at what it did. It finds x minus 6 squared plus y minus 6 squared, which it totally should. It's just that it expands it because that's what it does. And then this is supposed to equal 409 So I get this, and then if I subtract 409, I get this, which is what I had, so I didn't mess that one up. Treating things like vectors, I do that a lot. Oh, so where did the 409 come from, right? So what I did there essentially is the norm of 6, 6. So I'm just going to make a vector from one of the, basically from one of the endpoints of the diameter to the center. And then, so mine's A, let's say, is that, or I could have done from the center to the other one, or I could have done from A to B and then divided by 2 and gotten that. So any of those would be an option. So always be thinking about vectors. Like, can you use vectors to make some of these things faster on the calculator? The answer is almost always yes. So I try to do that whenever I can. So let me go back. And I mean, we're basically done. What I was gonna do is maybe try to write out some of the vector-y stuff. So this, for the radius, I did the magnitude, or the norm, of 6, 6 minus, what's 26, 3. 26, 3. So I used vectors for that. And then here, I also used vectors for this. I basically made a vector between the two endpoints and then found the midpoint of that. But I'm not gonna write that one down. But anyway, that's a little bit about circles. They're pretty straightforward. So I will be back in the next video to do some more stuff, and I will see you there.